Okay, so today class, we will have our new topic in linear algebra. We will proceed to next module, which is about vectors. At the end of this module, the students will be able to perform operations on vectors, compute for the inner product, norm of a vector, and unit product. And of course, find the distance between two vectors. So I'm sure you are familiar with vectors because this topic uh, was already introduced in your physics class or in your physical science subject. Okay. So sa physics, nadidiscuss ang vectors. There are two types of quantity, which is scalar and a vector. When we say vector class, that is a type of quantity that has both magnitude and direction. What are the examples of vectors? We have um, acceleration, okay? So it's an example of vectors. Ano pa? Yung may mga direction. We have also velocity, okay? And we have force, momentum, and the opposite of vector is scalar. Wala naman siyang direction. It's a type of quantity that has no direction. But of course, there is a magnitude. What are those? Mass, distance, speed, temperature. So those are example of scalar, but we will not focus with that. We will focus only on vector. And then we're going to relate it in mathematics. So the reader is probably familiar with vectors from their use in physics and engineering. A vector is a quantity that has both magnitude and direction. But mathematically, when we are talking about mathematics, we can represent a vector graphically in the plane by a directed line segment or arrow that has its tail at one point and the head of the arrow at the second point, which is illustrated in figure 4-1. So we will have, this is an illustration or an example of a vector. So it's like a ray. Of course, this is in a plane. So two vectors can be added together using geometric means by using the parallelogram law. So we can also perform operations on vectors. So it's almost the same on how we perform operations on matrices. To add two vectors, U and V, we place the tail of V at the head of U and then draw a line from the tail of U to the tip of V. So when we add two vectors, we're going to have a new vector that is the sum of the given vectors. So when we check, given vector U, okay, we're going to connect the, so we have the head and the tail. We're going to connect the head of U by the tail of V to get the sum. So this is the sum of the two vectors, U plus V. So while we can work with vectors geometrically, we are not going to spend any more time thinking about such notions because in linear algebra, we work with abstract vectors that encapsulate the fundamental properties of the geometric vectors we are familiar with from physics. So let's think about what those properties are. So we can add or subtract two vectors, giving us another vector. We can also multiply a vector by a scalar, so that's scalar multiplication, giving another vector that has been stretched or shrunk, form a scalar product or number from two vectors by computing their dot or inner product. Find the angle between two vectors by computing their dot product. Describe a zero vector. So it's almost the same. We have also zero matrices, right? And we also have zero vectors, which when added to another vector leaves the vector alone. So in properties of real number, it's like the zero property that when we add a number by zero, the answer is the number itself. So it's just the same in matrices. When we add a matrix by zero matrix, the answer is the matrix itself. So the same with vector. When we add a vector by a zero vector, the answer is the vector itself. And then uh, describe and find an inverse of any vector which when added to that vector gives the zero vector. So it's just the same also with the properties on real numbers that when we add two numbers by its opposite, so it's like a plus negative a, so the opposite of a is negative a, the answer is zero. So same with matrix. When we add matrix by its inverse, okay, the answer is also zero matrix. So it's just the same with vector. When we add a vector by its opposite vector or by its inverse, the answer is zero. And then represent the vector with respect to a set of basis vectors, which means we can represent the vector by a set of numbers. So the properties under real number is also applicable on matrices, but not all properties, right? Like the commutative property for multiplication, hindi siya applicable sa matrices. But some properties are applicable. Okay, it's the same with vector. And then this last property is going to be fundamental importance in linear algebra, where we will work with abstract vectors by manipulating components. So let us refresh our memory a bit by considering two basis vectors in the plane. One points in the x direction and the other points in the y direction. So remember, the basis vectors have unit length. So I'm not sure if this was discussed in your physics class, but we are going to relate it in mathematics. A given vector in the xy plane can be decomposed. So this is for uh, two-dimensional. So we have x and y. A given vector in the xy plane can be decomposed into components along the x and y axis. I'm not sure, hindi ko yata napakita yung figure na yon. Anyway, so the way we write this mathematically is that we expand the vector u with respect to the basis. We're going to discuss basis under vector space. That's another topic. So doon na lang natin siya bigyan ng attention. So we'll proceed to next. So we have vectors in Rn. So it means that the elements are real numbers and the n is the number of elements. So consider the set of n tuples of real numbers which are not more than list of n numbers. For example, we have vector u. The vector u has an element u sub 1, u sub 2, up to u sub n. Is a valid n tuple. So the number u sub I are called the components of the u. A specific example is if we have vector u, the elements of vector u, we have 3, -2, and 4. So where the mu is a vector in R3 because the elements are all real numbers and we have 3 elements. So we now consider some basic operations on vectors in Rn. Vector addition. So we can also represent vectors by a list of numbers arranged in a column. So this is called a column vector. Sa matrix, meron din tayo nito, di ba? And then, for example, we write a vector and we know that ang column class ay vertically, right? Arrange. So for example, we write a vector u in Rn as this. So this is vector u. This is a column vector. Vector addition is carried out component-wise. So it means that you're going to add the first element by the first element of the other vector. So u sub 2 will be added by b sub 2 up to kung ilan man yung elements up to u sub n, and also you're going to add it to b sub n. Specifically given two vectors that belong to the vector space Rn. So the size should also be the same. So when we add two matrices, we can add or subtract matrices if they have the same dimension, right, or size. So it's the same with when we add vectors. So we form the sum u plus b by adding component by component in the following way. So when we add u plus b given vector u and vector b, when we get the sum of the two vectors, so you will just add u sub 1 plus b sub 1, u sub 2 plus b sub 2, up to u sub n plus b sub n. Notice that if u and b are valid list of real numbers, then so is their sum. So it means that since this is vector space Rn, all elements are real numbers. So we know that we can add real numbers. And we have closure property or close property. It means that when we add two real numbers, the answer is also a real number. That is closure. So therefore, the sum of u plus p is also a vector in Rn. When you add two real vectors, the answer is also a real vectors. That is close under vector addition. So meron din kasi tayo, di ba, sa algebra na closure property. Under addition and also multiplication, yun naman lagi yung operations for real numbers, addition and subtraction. Since the operation here is addition, we have close under vector addition. Close or closure property. It's just the same. Okay, so let's consider example. So number 1, consider two vectors that belong to R3. So it means that the elements are all real numbers and we have the size. So given vector u and vector p, compute the vector formed by the sum u plus p. So when we add two vectors, make sure they have the same dimension. If they are, we can perform operations. We can find their sum and even the difference. So here, let's find the sum u plus b. So we will just add -1 plus 7, it's 6, 2 plus 8, it's 10, 5 plus -1, it's 4. So this is the answer. We have now a new vector. So we have 6, 10, and 4. If we have a real vector space, we also have complex vector space. So some of the elements, or maybe all of the elements, are complex or imaginary. We can also consider complex vector spaces a vector in Cn. So this is the symbol for complex, right? R is for real numbers, C is for complex number, Q is for rational, Q prime is the irrational. W for whole number. Ano pa? Integers, we use Z. So we have positive integers or C plus. So we also have negative integers or C negative. And then whole numbers, counting numbers or natural numbers, we denote it by N. So the letters symbolize kung ano yung mga elements niya. So we have here C. So it's complex. So some of the elements or maybe all of the elements are imaginary or complex number. So we can also perform operations given if it's complex or real. A vector in C sub n is also an n tuple, but this time we allow the elements or components of the vector to be complex numbers. Therefore, two vectors in C3 are. So it means that some of the elements are complex and we have three. Okay? Elements. So given this vector v, we have 2 plus I, 3, 4, I. So some of the elements are imaginary. Even for vector W, so we have 0, 1, negative I. By the way, class, ang given ay laging column vector. So most operations on vectors that belong to a complex vector space are carried out in essentially the same way. So it means that how you perform, how you add the real vector space is just the same when we add for complex vector space. So for example, we can together this vectors component by component. So you will add u sub 1 plus p sub 1, u sub 2 plus u sub 2, up to u sub n plus p sub n. So we're going to get the sum of p and w. So we will have 2 plus I plus 0, still 2 plus I. By the way, when we add complex numbers, so it's just the same how we add real numbers or integers. Okay, so 3 plus 1 is 4. 4I plus negative I is 3I. Okay, so I is like the variable x. So you add similar terms. Are we clear in adding real and complex? Next, scalar multiplication. Let U be a vector in some vector space. So we have vector U sub 1, U sub 2, up to U sub n. And of course, the alpha be a scalar. The scalar product of alpha and mu is given by so we have scalar multiplication, right, on multiplication on matrices. So we will just multiply the given scalar in each element. So we're going to multiply your scalar by u sub 1. So we will have scalar u sub 1, the alpha times u sub 2, alpha u sub 2, up to alpha times u sub n, alpha u sub n. So you will just multiply scalar in each element. So if we are dealing with a real vector space, then the scalar alpha must be a real number. If the given elements are real number or the given is a real vector space, your answer, okay, for that is also a real number. For a complex vector space, the scalar can be real or complex. Okay? So pag real vector space, ang scalar niyan ay laging real. Pag complex vector space, it's either real or complex. So let's have an example. Let alpha be equal to 3 and suppose that we have vector u and vector v. Find alpha u minus v. So one of the operations that we can also perform is subtraction. So before that, we will multiply the vector u by the scalar minus the v. So we will have 3 multiplied by negative 1, that's negative 3, 3 times 4, it's 12. 3 times 5, it's 15. And your answer, okay, we're going to subtract b from alpha u. Okay, so we will have negative 3 minus 0, it's negative 3. 12 minus 2, it's 10. 15 minus 5, 10. So kung paano tayo mag-perform ng operation sa matrices, ganun din sa vectors. Ito naman ay column vector naman siya, class. So same process lang din siya. Okay? Clear tayo? Can you follow? So dito sa first example natin, sa scalar multiplication, the value of the scalar is a real number. Therefore, your answer, the elements, okay? So, I mean, you're going to have also a real vector space. All elements are real numbers. Example 3, we have complex vector space. Our vector u, we have 2i and 6. Okay? And the value of the scalar is a complex number. Find alpha u. Okay, so we're going to multiply each element of u or vector u by 3 plus 2i. So when we multiply again complex number, always remember the power of I. We have I squared that is equal to negative 1. Of course, I that is equal to I raised to 0 is equal to 1. I cube, so I squared times I, right? So negative 1 times I, that's negative I to the 4th power. So it's like I squared times I squared, so which is equal to 1. And continue the process. Basta ganun siya sa power of I. Karaniwan naman ang may encounter nyo sa problem ay I squared. Hindi na naman lalagpas. Or maybe I to the 4th kasi merong I squared. Depende sa given, pero mostly hindi naman siya sobrang taas ng power. So given this, we're going to get the product. So scalar multiplication in a complex vector space also proceeds component by component. So you're going to multiply your given scalar value by each component or by each element. Therefore, we have the given scalar is 3 plus 2i, multiply in each component. So 3 plus 2i times 2i. 3 plus 2i multiply by 2i. So, it's this binomial by monomial. So, same lang din. Kung paano tayo sa polynomials mag-multiply, ganun din sa complex. So, 3 multiplied by 2i is 6i. 2i times 2i, so we will have 4i squared. Okay? Laging ang magiging sagot nyo, class, ay nasa form. This is the form for complex. A plus bi, where a and b are real numbers and I is imaginary. Okay? Laging ito ang standard form. So, when we simplify this, magiging ganito ang form lagi niya. Because I squared, that is equal to negative 1. So, we will have 6i plus 4 multiplied by I squared, that is equal to negative 1. So when we write our answer in standard form, this is the standard form for complex number, a plus bi. So 4 times negative 1, it's negative 4 plus 6i. That's why we have here negative 4 plus 6i. Okay? Sinulat ko yung sagot ko sa standard form for complex number. And then, 3 plus 2i multiplied by 6. So, ganun pa din. 3 plus 2i multiply by 6. So, we're going to multiply 3 times 6, that is equal to 18. 2i times 6, that is equal to 12i. So we will have here 18 plus 12i. Okay? So just remember this. So if you are rusty with complex numbers, recall that I squared, that is equal to -1. I times negative I, that is equal to, this is negative I squared, right? I squared, that is -1 times negative, so it becomes positive. Subtraction of two vectors proceeds in an analogous way as the next example shows. So we can also subtract. Are we clear? Sa scalar multiplication for real vector space and complex vector space.
Yes
Can
po.
you follow? All right.
Yes
Yes
po.
po.
Wait. Next is, our example is, how are we going to subtract two vectors? By the way, nagawa na naman natin ito. So let's have an example. In the vector space R4, find u minus v4. Given the vectors u and v, we're going to find their difference. So working component by component. So first element by the first element, second element by second element. So we have here R4. So it means that all elements are real numbers and we have 4 components. So we're going to get their difference. So u minus v. So 2 minus 1, it's 1. -1 minus 2, -3. 3 minus -5, so it becomes positive. 3 plus 5, that's 8. 4 minus 6, that's -2. Okay, so ganun lang. Madali lang, di ba? Next, the zero vector. To represent the zero vector in an abstract vector space, we basically have just a list of zeros. All elements or all components are zeros. That is zero vector. So the property that a zero vector must satisfy is u plus 0 or 0 plus u, that is equal to u. Okay? Any vector, when we add by zero vector, the answer is the vector itself. For any vector that belongs to a given vector space, so we have, so yun siya, u plus 0. So we have vector u, this is plus, sorry, this is plus the zero vector. The answer is the given vector. So u sub 1 plus 0, u sub 1, u sub 2 plus 0, u sub 2, up to u sub n plus 0 is u sub n, which is, this is the given vector, this one. The inverse of a vector is found by negating all the components. So given vector u sub 1, u sub 2, up to u sub n, then get the inverse of this. That is the negative u. So the negative of u sub 1, negative u sub 1, negative of u sub 2, negative u sub 2, up to the negative of u sub n, negative u sub n. When we add two vectors by its inverse, the answer is a zero vector. Okay, that is equal to 0. Or this is, it is sabi ko kanina, ano nga bang ano to? Additive inverse, right? Sa real number. When we add two real numbers, but when we add a real number by its inverse, the answer is 0. Or u plus negative u, that is equal to 0. And we also have transpose for vector. Diba sa matrix, we will just interchange your row by column. So it's just the same. Given a column vector, your answer will become a row vector. So we now consider the transpose of a vector in which is a row vector. For a vector, given this vector u, when we get the transpose of that, we denote also transpose this like this one. U, uh, ano bang ano to? U, pag sa taas, but U transpose. So we read this U transpose. So from column vector, we're going to change it to row vector to get the transpose of a given vector. So find the transpose of the vector V. So 1, -2, 5. So to get V transpose, we will write this column vector into row vector. So we'll just interchange. So this is the answer. 1, -2, 5. Okay? Find the transpose of U. So this is real vector space also. So we will have U transpose. You will just interchange this into row vector. So we will have this 1, 0, -2, 1. For vectors in a complex vector space, the situation is slightly more complicated. So our previous examples is more on real vectors. Okay. Vector U in Rn, even vector V. This is also in Rn. We also perform, or we can also get the transpose for complex vector space. Medyo madadagdagan lang. Like we did in Hermitian nung last time natin sa matrices, 'di ba meron tayo doon Hermitian conjugate kasi merong mga elements or some of the elements or maybe all of the elements on the given matrix are complex or imaginary. So ang ginagawa natin, we find first the transpose of the given and then the conjugate. So same here for complex vector space. We call the equivalent vector the conjugate and we need to apply 2 steps to calculate it. So same process class. Kunin nyo muna yung transpose ng vector and then the complex conjugate. Again, the complex conjugate, A plus BI, when we get the complex conjugate of that is A minus BI. Because class, one of the properties ng complex, the product of complex conjugate is a real number. Okay? So just remember, get the transpose and then the conjugate of each component. This is the symbol. Again, magkaiba ang symbol ng transpose sa complex conjugate. So sabi ko nga, itong cross na to, that is for Hermitian, right? Kaya ganyan pa din yung symbol. Okay? Okay, when we have complex vector space, we need to get the transpose and then the complex conjugate of each component. So this how we denote conjugate, pa-cross. The conjugate of a vector in a vector space is written as by this. Tayo. Tayo mag-next. Okay, so let's have an example. Let vector u be equal to 2i and 5. Calculate the complex conjugate. Or that is also Hermitian conjugate. So kunin muna ang transpose nito from, so we will have u transpose, we will have 2i and 5. Okay, and then to find the conjugate of 2i, that's -2i. When we get class the conjugate of a real number, it's just the same. nagpapalit lang tayo class ng sign doon sa may I o yung may complex. Okay? That's why the conjugate of 5 is still 5. That's it. Okay? So another example, find the conjugate of vector B. Get the transpose of this first. So from complex vector, we're going to write this to row vector. So we will have 2 plus I, 3I, 4 minus 5I. And then get the conjugate of each component. 2 plus I becomes 2 minus I. So this is now the symbol, yung cross. Kasi na magko-conjugate na tayo eh. 2 plus I becomes 2 minus I. 3I becomes negative 3I. 4 minus I, the conjugate, is 4 plus 5I. Are we clear?
Yes po.
Okay, next. We will proceed now to dot or inner product. We needed to learn how to write column vectors as row vectors for real complex vector spaces because this makes computing inner product much easier. Na-encounter nyo na to sa matrices class, tong dot or inner product. When we multiply row matrix by column matrix, okay, the answer is a real number. Dito maraming nagkamali sa exam. Kasi meron ako doon nilagay naka-matrix. Ang size ng matrix ay 1 by 1. Hindi ko maalala yung number. Pero halimbawa yan siya. This is still a matrix. Iba yan. That is not equal to 11. This is a real number, but this is not a real number. Naka-matrix siya plus. Meron kasi siyang bracket. So, hindi sila equal. Sabi natin, when we multiply row matrix by column matrix, the answer is a real number. That's why maraming nagkamali sa exam kasi ito yung pinili nila na dapat ito. Eh wala nito sa choices. So none of this. Okay? So yun, ang tawag doon class ay inner product. So wala to. This is multiply. We needed to learn how to write column vectors as row vectors. So yun yung ginagawa natin when we get the transpose from column nagiging row. We also do that for real and complex vector spaces because this makes computing inner products much easier. The inner product is a number, okay? Is a number, and so it is also known as the scalar product. So we also call dot product or inner product scalar product because it's a real number. In a real vector space, the scalar product between two vectors, given vector u and vector b, when we get their product. Sorry, wala to class ha, kasi we're going to multiply row and column vectors. Given the u and v, how are we going to get their inner product? U transpose your u. So this is column vector, it becomes row vector. Laging yung una, if we're asked to find the dot product of UV, U transpose your U, and then multiply it by column vector by your B. Okay? Diba ang ginagawa natin, U sub 1 multiply by B sub 1 plus U sub 2, B sub 2, up to U sub n multiply by B sub n. This is also the same with this. That is the summation of U sub I, B sub I from 1 up to n. Okay? So let's try example. Let vector U be equal to 2, negative 1, 3, and vector B 4, 5, negative 6, and compute their dot product. So we will find UV. Okay. So we will transpose this, your column vector by, may equal na naman, by column vector into row vector, multiply by B. So again, wala tong equal sign na to, class, ha? By your V, so 2 multiplied by 4 plus -1 multiplied by 5 plus 3 multiplied by -6. So we will have 2 times 4, it's 8, -1 times 5, it's -5, 3 times -6, it's -18. So 8 minus 5, it's 3 minus 18, -15. So our answer is a real number, not a matrix. Okay?
Yes, ma'am.
If the inner product of two vectors is 0, we say that the vectors are orthogonal. So if you have the answer 0, okay, when you get their inner product, we call that orthogonal. So number 10, show that vector U and vector V are orthogonal. So we will have UV. So transpose this, we will have 1, -2, 2, may equal sign na naman. And then multiply it by B. So 1 times 2 plus -2 times 5 plus 2 times 4. So 1 times 2, it's 2. -2 times 5, it's -10. 2 times 4, it's 8. So 2 minus 10, it's -8 plus 8. The answer is 0. So therefore, this is an orthogonal because the answer is, okay, when we get the inner product of two vectors, that is equal to 0. Okay? Next. So that is for inner product for real number vectors, for real vector space. So how are we going to compute inner product for complex? We compute the conjugate of the first vector. So we will compute the inner product, UV. So kailangan yung kunin, you transpose your U and then get the conjugate. So it's like for Hermitian. Okay, pag complex vector space, laging ganon. Ta-transpose nyo muna, kunin ang conjugate. Okay? And then, you multiply it in each component of the other vector. So, this asterisk means you get the conjugate of the U. Okay? So, let's have an example. Find the inner product of U and V. So this is for complex vector space because some of the elements are complex. So we transpose this, and then when we transpose, we will have 2i and then 6. Get the conjugate. The conjugate of 2i is -2i. Conjugate of 6, 6. And then multiply it by the v. -2i times 3, it's -6i. 6 times 5i, that is equal to 30i. So simplify, -6i plus 30i, the answer is 24i. Since they are similar terms, we can combine them. The answer is 24i. Okay? Since some of the elements are, by the way, this is also in standard form class. Okay? The value of A is just equal to 0. Okay? And the value of B here is 24. Okay? The answer is 24i. If other elements are complex, the value of the inner product, okay, pwedeng magkaroon din ng real pag na-simplify, but mostly it's also a complex number. Okay? Next. The norm. The norm of a vector. So we carry over the notion of length to abstract vector spaces through the norm. The norm is written as, so this is the symbol. This is how we denote norm of a vector. Dalawa yung line niya. Kasi di ba sa absolute value, isa lang. So dito, tag-dalawa sila. And is defined as the non-negative square root. When we say non-negative, hindi siya negative. It's a positive square root. Okay? So it means that's the principal root of the dot product. Pero kasi sa inner product or sa dot product, UV. Pero pagdating sa norm, sa sarili niya. Okay? More specifically, we have, if we get the norm of U, that is the square root of UU. Okay? So how are we going to get the UU? The norm must be a real number to have anything as a length. Okay? Dahil we're talking about length, it's always positive. This is why we compute the conjugate of the vector in the first slot of the inner product for a complex vector space. So we illustrate this more clearly with an example. Kasi class, when we multiply, yun nga, nasabi ko na kanina, when we multiply a complex number by its conjugate, the answer is a real number. Kaya sa complex vector space, kinukuha muna ang conjugate niya. Once we transpose, get the conjugate. Kasi pag pinag-multiply na yon, yung complex conjugate, the answer is a real number. And we're talking about length. At dapat lagi siyang positive. Okay? So find the norm of vector V. So this is complex vector space. Kunin muna natin ang transpose nito. So we will have 2i for 1 plus I. And then get the conjugate. The conjugate of 2i, negative 2i. The conjugate of 4, 4. The conjugate of 1 plus I is 1 minus I. So multiply it by itself, 2i, 4, and 1 plus I. Kasi kukunin natin ang norm classes sa sarili niya. Diba kanina kasi UV sa dot product. Ito naman sa norm niya, sa sarili lang niya. Okay? And then, so may equal sign na naman. Edit ko na lang kung module nyo. So negative 2i times 2i plus 4 times 4 plus 1 minus I multiplied by 1 plus I. So ito na siya. When we multiply by a complex number by its conjugate, magiging real number na. So papakita natin kung paano. So negative 2i times 2i, we will have negative 4i squared. So when we simplify it, I squared, that is equal to negative 1. So the answer is 4. Kaya nakuha si 4. 4 times 4, it's 16. Kapag nagmumultiply tayo, class, by its conjugate, ng complex number by its conjugate, ang imumultiply nyo na lang dyan, para yung difference of two squares magkakaroon tayo ng a squared minus b squared, di ba? That is equal, this is difference of two squares, a plus b times a minus b. Ang imumultiply mo na lang, first to first, last to last term. 1 times 1, the answer is, so 1 minus I multiply by 1 plus I. Multiply lang ang first to first, last to last term. 1 times 1, that is 1. Negative I times I, negative I squared. And then simplify. 1 minus I squared, that is equal to negative 1. So the answer is, when we simplify this, that is equal to 2. Okay? Tingnan nyo. Pag nag-multiply ka ng complex number by its conjugate, ang sagot ay real number. Kaya nakuha tong 2. And then combining like terms, 4 plus 16, 20 plus 2, 22. Okay? Kasi ang norm, we're talking about the length. Okay? So it's always positive. Okay? So the answer is 22. But sabi natin, the norm is a non-negative square root. Once you get this, BB, get the square root of this, which is square root of 22. Okay? That is the final answer. Hindi ito. Kasi sabi natin, the definition of the norm of a vector, that is non-negative square root of the dot product. So the answer is, the final answer is square root of 22. Is that clear how to get the norm of a vector?
Yes po.
Next. So sabi class, note that the dot product of u that is greater than or equal to 0. Because we're talking about length, wala namang negative. It's always from 0 pataas. Or any vector u with equality only for the 0 vector. Next is unit vectors. So we have dot product, norm, and then unit vector. Magkakadugtong kasi sila class. Yung topic na yan. So a unit vector is a vector that has a norm that is equal to 1. So this is how we denote unit vector. Merong parang, ano ba yan? Curve sa taas niya. So we can construct a unit vector from any vector by writing. So this is the unit vector of V that is equal to vector B over this is the norm of B. Okay? So a vector, so let's have example. A vector in a real vector space given the vector W. So we have 2, -1. Use this vector to construct a unit vector. So kailangan muna natin kunin ang norm. Ang norm ay dapat sa sarili. So we will, since this is just a real vector space, so double dot product ng W, right? So you will have row vector of this 2, -1, multiply by itself 2, -1. Okay, so we will have 2 times 2, that is equal to 4, -1 times -1, that is equal to 1. So the answer is 5. Okay, and then we know that norm is the square root. Dahil sa sarili naman to, the square root of this. So we'll have square root of 5. And then how to get the unit vector, just follow this formula. W over the norm. 1 times W, that is equal to W. And our norm, that is equal to square root of 5. Multiply by the given W, vector W, 2, -1. Okay? And then, scalar multiplication. Multiply each component by the scalar. So 2 multiply by 1 over square root of W. Dapat wala na tong si W. Bali ganito yan, class. W over the norm that is equal to, this is also equal, pinakita lang yan sa 1 over the norm times W, which is 1 over, may kulang dito eh. 1 over the norm is square root of 5 times W. Ang W natin ay 2, negative 1. So, saan may kulang? 1. And then, scalar multiplication. 1 over square root of 5 times 2. That is 2 over square root of 5. 1 over square root of 5. This is our scalar class. You're going to multiply it in each component. 1 over square root of 5 times negative 1. That is negative 1 over square root of 5. Saan galing yung 1? Galing ang 1, eto class ay equal din dito. Diba? Kasi 1 times W, W over this. Diba? And, so when we follow this, 1 over your norm, square root of 5, and W, that is equal to this, to negative 1. Is that clear? And then, scalar multiplication, we're going to multiply each component by the given scalar. 2 multiplied by 1 over square root of 5, that is 2 over square root of 5. And then negative 1 times 1 over square root of 5, that is equal to negative 1 over square root of 5. And then we rationalize, right? 2 over square root of 5. Multiply the numerator and the denominator by square root of 5 para maging mawala yung radical symbol, right? So 2 times square root of 5 to square root of 5 over 5. Kasi square root of A multiply by square root of A, the answer is A. So yun siya. And same here, negative 1 over square root of 5 multiply the numerator and the denominator by square root of 5. Bakit tayo nag-multiply? Kasi ito class ay equal din naman sa 1. Ibig sabihin, parang ito din, yung given. Ba, 2 over square root of 5 times 1, same lang ng given. Ginagawa natin to para mawala ang radical symbol. We rationalize. So we will have negative square root of 5 over 5. Kaya yun siya. Negative square root of 5 over 5. But anyway, nagawa naman natin yun sa trigo, di ba? So that is the unit vector. 2 square root of 5 over 5, negative square root of 5 over 5. This is the final answer. And we call this procedure normalizing or normalization. We normalize the vector. So we call this procedure normalization, or say we are normalizing the vector. Okay? So next, are we clear? Any question? Are we clear with dot product, norm, and what's this? The unit vector? Clear tayo sa tatlo? Magkakadugtong kasi sila. May tanong pa ba doon? Do you have questions, clarification?
Wala po, ma'am.
Okay. Next. Good din palang naka-cellphone ako kasi nakikita ko yung nagchat-chat. Pag nagchat kasi kayo pag sa laptop lang, hindi ko siya nakikita. So nakita ko kanina may question pala. Anyway, so let's continue. The angle between two vectors. The angle between two vectors, U and V, is cosine theta equals UV. This is inner product over the norm. The norm of U, the norm of V. Pero hindi na natin yan. You will just need to follow this. To find the angle, dahil ang given ay cosine theta, you get the inverse. Kung ano man yung value na makuha dito, dahil ang value naman dyan, class, ay real number. Yan. Para makuha ang theta, the arctan, or the arc cosine, or the inverse of cosine to get the theta. Pero hindi na natin yan i-discuss kasi yan ay hindi naman talaga kailangan pa. We'll just introduce, just follow this. And we also have two theorems involving vectors. The Cauchy-Schwarz inequality states that, so the UV, or the dot product, that is less than or equal to the product of the norm U and the norm V. And we also have the triangle inequality says that the norm of U plus B, that is less than or equal to the norm of U plus the norm of B. Okay, next. Distance between two vectors. We carry over a notion of distance between two vectors. So this is given by the distance of UB, that is the norm of U minus B. So that is equal to the square root of the square root of U sub 1 minus B sub 1. This is distance formula, right? The square root of U sub 1 minus B sub 1 plus the square root of U sub 2 minus B sub 2 up to the square root of U sub n minus B sub n. This is distance formula. So find the distance between vector U and B. This is in R3. So we need to get first the difference. So the difference of the two vectors. So that's U minus B. So 2 minus 1, it's 1. Negative 1 minus 3, it's negative 4. 2 minus 4, it's negative 2. And then, since this is norm, right, the symbol, the norm of U minus B, sa sarili niya. U minus B and U minus B. Kanina kasi, W, W. Or yung sa una, UU. So ngayon, dahil ang given natin ay norm of U minus B, we will have to find that's U minus B, U minus B. Anyway, you will just need to transpose the first, okay? Para makuha. Hindi ko na class sinulat dito ng buo kasi ay nilagay kasi mahirap i-type. So you will have, write this in row. 1. Anyway, real numbers naman sila. So real vector space naman. 1, negative 1, negative 4, negative 2 multiply by itself. 1, negative 4, negative 2. Okay, so you will have, this is for the norm of U minus B. 1 times 1, that's 1. Doon kasi sa formula for the distance, that is squared. Okay. Pakita ko lang. This 1. Okay? My squared. So we will have 1 squared. Wait, 1. Mamaya na nga. 1 times 1 plus negative 4 1 times 1 plus negative 4 times negative 4 plus negative 2 times negative 2. So we will have 1 times 1, 1, negative 4 times negative 4, 16, negative 2 times negative 2, it's 4. So we will have 1 plus 16, 17 plus 4, the answer is 21. Get the distance of the norm of U minus B. So you will have, and so the distance function gives this. the square root of this. Ito ay the norm, the the non-negative square root. So square root of this, square root of 21. So you will have this. Kasi 'di ba ang norm ay distance din, that is the length. Pero ang pagkakaiba lang, kinuha kasi muna natin ang difference. Unlike kanina, when we are just find the norm of u or the norm of the given vector, we just need to multiply it. Okay, transpose the first vector and then multiply it by itself and then the square root. Ito kasi kinuha muna natin ang difference ng two vectors. Okay, to find the distance of the two vectors, you need to get first the difference and then the inner product, okay, the norm and the norm. Okay, so yun siya, which is square root of 21. Any question? So that's the end of module 4, vector. Do you have questions, clarification? For your practice exercise, iksi lang naman yung sasagutan nyo. So you will have 1 to 6. Number 1, get the sum and difference. 2, scalar. 3, inner product. 4, norm of the vectors. So each vector get the norm. And number 5, normalize the vector. So yan ay sa unit vector. And then number 6, perform the operations for A, B, and C. U plus 2B minus W for A and B, 3W, C, negative 2U plus 5B plus 7W. Then the norm of each vector, vector U, vector B, vector W. And then normalize each vector. Get the unit vector of U, unit vector of B, unit vector of W. That's it. Question class. So 36 lang kayo today. Do you have questions, clarification?
Wala naman po.
Okay. So if you don't have any questions, that's all for this day, class. So we will have our next class ng 1 o'clock. Okay, for our history of mathematics. Can each group summarize their presentation? Kasi sobrang haba nung iba. Tapos yung iba binabasa lang naman yung nasa PowerPoint. Can you do it later? Yung chapter 3, 4, 5, and 6. Summary ng bawat chapter.